Hello, this is Matthew, and welcome to today's video on the PIC system, or more generally, multi-value databases. Ever since I did my video series on the M programming language, originally known as MUMPS, I've had a couple people reach out and ask me if I have looked at or if I could do some videos on PIC style systems. And it makes sense that they'd ask that in relation to mumps because they are similar in many ways and they came out around the same time. If we switch over to a browser here, looking at the history of PIC, you can see development was in 1965 was when the original sort of incarnation of the database came out. And then it became a full-fledged commercial offering with really the core set of features that multi-value systems still have today in 1973. So if we look at, let's just look at MUMPS Wikipedia. I don't want the virus, I want the programming language. Here we go. We can see here that MUMPS first appeared in 1966. So yeah, 1966 versus something that has the origins in 1965. We're really talking about the same time frame here. And if we go down and look at the history of it, we can see that it started out being named the Generalized Information Retrieval Language System, or GIRLS, and was in fact originally implemented on an IBM System 360. So relevant to my channel title of Mainframes and More with Matthew. And it was later renamed as the part of the commercial release as the PIC operating system or the Reality operating system. And the reason it's called PIC is derived from one of the original authors, Dick Pick, who's then the one who went on to work with microdata and port it to other platforms. And it has, in the end, stuck with his name. So this was originally written for a specific purpose. It sounds like Don Nelson and Dick Pick were at TRW, and they needed to put together a database system to track the inventory and parts of the ill-fated, never really went into production Cheyenne helicopter project. So like MUMPS, which was originally purpose-built sort of in the lab in industry, in this case, the healthcare industry at a hospital, to build a database to handle electronic patient records. The PIC system was developed to be a database system to handle a particular task, in this case, inventory control of helicopter parts. Then became a commercial product. And again, if you're interested, you can go on and look at the rest of history here. But it really did spawn the sort of original commercial implementation. And then Dick Pick went on to form PIC Systems, which made the actual release called the PIC System. And it was licensed to a number of companies to port to other platforms. And in the end, we got a lot of just different commercial releases, Universe, Unidata. We can see here some others. JBase is actually an interesting one. Univision, OpenQM, which turns out to be very important for us, D3. And kind of like how in the MUMPS world, all of the commercial MUMPS implementations really got acquired over time and aggregated under the company called InterSystems. In the PIC world, the vast majority of the commercial implementations, which really they were all commercial implementations, other than a GPL release at one point in history of this OpenQM product, which was also a commercial product, had a commercial version available. They were really all, closed commercial systems. But anyway, they all consolidated under Rocket Software, who, aside from now being the owner of the vast majority of the multi-value database products, is also just so happens to be very active in the IBM mainframe world with a lot of mainframe related products and services. In any case, this PIC operating system, it started out, as the name implies, as the whole operating system to run on the computer. It started out on that S360 mainframe, but then it spent, I think, the majority of its early life being ported to microcomputers, and then eventually, to mini computers, and then eventually to microcomputers as well. And so there was, in fact, it came out in the mid 80s and was maintained into, I think, the early 90s, the PIC operating system for the IBM PC. So that's what I have running over in one of these screens here. Yep, over here. So I just have a QEMU VM running that has the PIC operating system installed. And then I just have a web-based VNC viewer here that lets us interact with the VM and see the monitor. Now, when we talk about a multi-value database system, again, this is the database concept, the database model that the PIC system is built around. I can go over to a diagram here. We can sort of talk through it. So most of us are familiar with SQL databases or the relational database model, where you have these things called tables, and a table has several columns. So for example, if I want to build a database to hold some information about the planets in the solar system, I want to know a little bit about the planet, I want to track all of the planet's moons, and I want to track the probes that we have sent to fly by or orbit or whatever, investigate the planet. So I might make a planets table, and that would have maybe 3 columns: an ID. I might use the planet's order of orbit, so 1 for Mercury, 2 for Venus, 3 for Earth, and so on. It's often referred to as the primary key. It's a unique way to identify this record. And then I'll have a couple other columns for example, the name and the radius. These may have data types associated with them that restrict what I can put in them. And then for the moons, because I'm going to have potentially multiple moons per planet, I would make another table for moons, and moons might have their own ID, and they would be related to a planet by the planet ID. So the planet ID ties the planet to the moon, and then I'd have some columns about the moon. And same thing for the space probes. I'd have a relationship to the planets based on planet ID, and I'd have a couple of attributes or columns in SQL tables. And then I could declare one-to-many relationships here. So one planet can have many moons, one planet can have many probes. So that's the typical way to do it in a SQL or a relational database today. In a multi-value database, we use slightly different terminology, and we don't break things up into this normalized form like we would in a relational database. So multi-value databases consist of files. So what you might call a table in another database, you would call a file in multi-value. So I didn't label it here, but this might be the planets file. I'm trying to write somewhat legibly with my mouse here. Anyway, you get the idea. So that's going to be the planets. So we have a planets file, and each file has 1 or more, or I guess 0 or more records or items. So a row in a database table and in a relational model could be called a record or potentially an item in the multi-value file. And the items in multi-value files are really nothing more than key value pairs. So a multi-value database is really just a key value database with a lot of different files to put your different types of data in. And so every multi-value file has a single key and then a single data value. And so in this case, for Earth, right, the data value is all of these attributes. And for Jupiter, it's all of these attributes. Now, internally, the way that it stores this is it uses or so I should first say that every value is stored internally just as ASCII text. So the name Earth, of course, is just the ASCII characters for Earth. If we're talking about the radius, this wouldn't be converted to a, say, binary representation of a 32-bit integer like it might be if you declare a table with a column called radius with a type of integer. This will just be stored in the database as the ASCII character for 6, the ASCII character for 3, for 7, and for 8. And the comma you probably wouldn't store in it. We'll talk about the masks for that when we actually get into the system. But all of these things are just stored as ASCII values. So there's also then in the data for a given key, there's going to be what's called the field mark. And this is actually just the byte value for it's implementation dependent technically, but most systems these days, I believe, use character 254. And if you have, so there'd be a field mark between each of these values. And then this would just be, again, the key 3, which there's a way that the ID or the key is indexed for quick lookup. And then it would just have a value of the ASCII text Earth, character 254, 6378, character 254, Luna, character 254, 1738. And same thing for our Jupiter entry down here. But this is where it really differs from how we modeled the data in a relational model, is instead of having to have a different file with moons and somehow relate them, for a given attribute in a multi-value file, you can have multiple values. And so just like it stores this field mark between each of the attributes, it stores a value mark between each of the values in a single attribute. So in the database, this is really going to be stored as the ASCII text IO, and then the value mark, which a lot of systems use the character value 253 for. And then Europa would just be ASCII text next to IO value mark, Europa value mark, Ganymede value mark, Callisto value mark. And then after that whole sequence of all of the values in the moon attribute delimited by this value mark, you'll have another field mark to move on to the moon radius. And again, all of these values would have a value mark between them. And then you'd have another field mark. You'd have Pioneer 10, value mark, Pioneer 11, value mark, field mark, because we're done with the values in that attribute. And then you'd have the date, value mark, and the date. And then that is that whole record. So it essentially just flattens everything out into delimited subfields, if you will. Again, they tend to be called attributes in these multi-value systems. And it's just, again, one big long string of essentially ASCII text that is then delimited by these field marks and these value marks. And then there are actually sub-value marks or item marks, I think they might be called. So there's a couple more levels of delimiter that you could have, but usually it's just values inside fields or attributes. Now that sounds kind of messy, but the query tools and the programming language built into the system is obviously built around the idea of supporting all of this. So in the end, if you take away all of my annotations here, you do end up typically seeing the data in this format. You'll see Jupiter, you'll see all its moons listed next to the Jupiter record, you'll see all of its probes listed next to the Jupiter record. And that's really the essence of the multi-value database. So enough with that. Let's just go ahead and look at what the system can do. So I'm going to switch back to that pick system install here. So we'll take a quick look at this older sort of classic operating system version of pick. And then like mumps, after computers started becoming a little bit more powerful, have some more memory, rather than needing to really use the entire set of resources for the computer to have some room for the overhead of the operating system and all of this. The multi-value type databases got ported to just be regular applications that run on normal operating systems, be that a bunch of Unix varieties or probably some mainframe operating systems or under some of the various mini computer operating systems. So the reason that this wasn't just a program that ran on DOS on your PC, the reason it had to be the whole operating system was because it is in fact a multi-value, multi-user virtual memory, supported multiple terminals connected via serial ports, right? So you could really have a multi-user interactive time-sharing operating system running on your old IBM PC. And in this case, right, it has different user accounts. So sysprog, the system programmer, is the built-in default admin account. We can log off of that account, off. And this particular R83 release of the PIC system comes with a little tutorial built in that has a pre-made database. So I think that'll be the best way for us to explore just the basics of what this database is kind of about, really what this whole system is about. So I log in as tutor, and the system here, if I list the files, we can see here that we have a file called customer, and it actually has a dictionary associated with that, and we'll talk more about that later. So one of the like I started out saying, when I did the video on mumps, people asked about PIC, and they came out about the same time. The concept is the same, and that they were operating systems that ran on the computer, and so they really had to provide everything you need. Now, they really do feel like very different systems, though, when you actually get into them. Mumps, I would describe as primarily a programming language that happens to have a database built in. So mumps has that sparse associative array global storage. And so when you're writing your programs in the mumps language, you can just refer to what are called global variables, and they can be indexed with really several levels of depth of indexing. And those global variables just conveniently get persisted to a database. But the main interface to mumps, if you log into a mumps terminal, you're at a prompt where you can really only type mumps code. There's no separation between the sort of shell commands, the terminal language, and the mumps programming language. And the mumps system itself doesn't know anything about your database or how you're arranging your data in those global variables. Whereas the PIC system here is really, like I said, mumps is like a programming language that happens to have a database built in. The PIC system here I would describe as a full-featured database platform that happens to have a programming language built in. And the programming language, by the way, in these PIC systems and the multi-value systems is in the BASIC family. So PIC BASIC, or various vendors name their various implementations different things, QM BASIC, stuff like that. And so it's a basic type language that then has some additional keywords and functions for operating on the database files on the platform. So in PIC, we're sitting at what's called the TCL prompt, the terminal control language, terminal command language. And this is how you interact with the system. If you're not in an application that somebody wrote for you or that you wrote yourself, you're just directly logged in to PIC, and you're here at the TCL prompt using TCL. And this is where you have commands like create file to create new files, or delete file. We have commands like list U to list the users on the system. It's aware of the date and time. So this is the TCL prompt. And again, in MUMPs, there's really no equivalent to the distinction between the programming language and the interactive prompt commands and all of that. You just sit there and you type in MUMPs commands if you're at a MUMPs prompt. So because this is really a full-featured database environment, it has a whole query language as well. So in addition to these TCL commands, in addition to the pick basic programming language, it has a query language called Access or English Access, because the goal was that it's very English-like. And I think, yeah, this predates the SQL query language as well. So I have that, if we do list files again, we have this customer file. So the customer has columns like the company name, their city, their zip code, their telephone number, and then the invoices for that customer. And because this is multi-value, the invoices are 3 multi-valued fields for the invoice number, the invoice amount, and the date. So if I want to start seeing the customers, I can just say list and then the file I want to list, customers. And this is that access query language. And I'm getting a list of customers. So I can see here that we have a customer with ID 1007. So that's going to be the key for this record in the file. And then I have all of the fields or the attributes for this customer. And you can see here that we do have these multi-valued fields, right? So invoice number 10287 sort of corresponds to that amount, and it corresponds to that date. And then the next invoice number corresponds to these things. This view that we see here obviously isn't the best for kind of teasing out what all of this looks like, but this is just listing every field, and it doesn't fit to do it in a sort of table view. So we're just getting everything printed out here. And if you go through, you can see there's just several customers in here. If you hit Control X, that'll cancel the listing. So I can also say list the customer file, but just give it some specific columns. So if I'm just interested in the company, we saw that was one of the fields here, and I'm interested in their city, and then maybe I want to see all of their invoices. I want to see maybe the invoice number followed by the date followed by the amount. So if I run that query, it still doesn't quite fit. So I'm actually going to, let's cancel that listing. Maybe we'll leave off the city. So let's say list customer, the company, and then their invoices. So what did I do? Invoice number, the date, and the amount. There we go. So now, because it can fit on a screen, just barely, it's squeezing it in here. You can see that we're getting the customer ID, the company, and now it's formatting all of those multi-value fields as their own rows of output here. So I can see this invoice on this date was this amount, this invoice, that's the data for it. And then when we go down to the next company, right, I'm now looking at a new company with a new list of invoices. So the system does know, again, how to format these things when they're shoved in to these multi-value fields or attributes. And it'll go through and show me all of the companies there. Now, the companies are kind of in a random order. So we've just been using the list command, which will give you everything just in the order that they're recorded in the underlying database files. So normally what you would do is instead of saying list, you would just say sort. And by default, this is going to sort by, I think, the ID. There might be a way to change the default, but if we do sort company, and then again, we'll do the invoice number, and then maybe we'll do the amount and the date. I think that might display a little bit more nicely. Oh, I forgot to say what file I want to sort. So sort customer, company, invoice number, amount, date 1. Here we go. And yeah, we're still getting one of the fields is sort of stomping on another field, but that's okay. So now we're getting them by the customer number. You can see they're sorted 0, 1, 2, 3. Well, maybe I want to see by company name, right? So you just say sort customer by company. And then I can say the fields I want. I can say company, and maybe we'll just go back to company and city. Now you can see instead of sorting by that ID by default, it is in fact sorting by the company name. So this, again, if you saw my mumps videos or if you know about mumps, I know I keep referring back to that. But certainly mumps doesn't have anything like this built in. We had to install that FileMan package to get kind of a database management and query capabilities, reporting capabilities, all of that on top of mumps. And that FileMan package, that's a big package that's been developed over decades at the U.S. Department of Veterans Affairs for the VA health system, and it's released under the public domain. So obviously there are, people build applications in mumps, and it has the capability of doing this kind of reporting, but this is just all built in to the PIC system itself. And really all of the multi-value database products have this this sort of English access query language that can do this kind of reporting. You can also do, just to sort of drive the point home, the built-in capabilities as a database and reporting platform are pretty complete, and that you can do things like, we'll sort the customer table, and I want to break on the company name. So I want a separate section of the report for each company. And then I want to total up the amount of their invoices. And maybe I still want to show the invoice number and the invoice date. Let's see what we get here. Yeah, so you can see here that for every company, we break between every company to show a total of the fields that I wanted a total of. So here for the first company, we get a total of all of their invoices. For the second company, we get a total for all of their invoices. And as you go through the pages here, you of course get that for every company. Now, maybe you don't want all of the invoices. You just want the company and the total of all of their invoices. You can run that same sort of query. So sort customer, break on company, total the amount, but then you can say detail suppress. So there are a couple of these options that you can put in your queries. Detail suppress is one of them. That will suppress the line item details of the multi-valued attributes that you're then producing things like totals for. There's ID suppress if you don't want to display the ID column. Remember, we're just listing the fields, the attributes we want, but the key, which is not one of the attributes in the values, it's the key that you index this particular file on, shows by default. So you can say ID suppress if you don't want to see that. So if we run that, now we get our report of the company and the sum of that company's invoices, and that's all we see. We're not printing out the details anymore. So you get the idea here. This English access query language is pretty powerful for, it's oriented toward business reports, obviously. You can imagine this was a system that was sold into businesses to keep track of their data and produce reports for management, for decision-making, quarterly reports, all that kind of stuff. So you can do a lot with that. Now, we also talked about data storage a little bit. If I list my customers again, so let's take a look at customer 1007. You can see here that the phone number is displayed like a phone number, right? We see parentheses, we see the dash. You can see that the amounts are displayed as dollars with commas and cents. And you can see that, of course, the dates are displayed in a date format here. Now, if we look at this customer 1007, if we actually just look at the data as it's stored in the database, we can do that with I think CT stands for copy to terminal. So I'm going to copy to terminal from the customer file, record 1007. Now, I talked about how internally these are stored with the field mark between each attribute. Pretty much universally in the system, in the line editor and in this copy to terminal thing, it's going to show it's going to actually remove the field separator, the field mark, and break it up into these numbered lines. So I have, field 1, attribute 2, attribute 3, attribute 4, so on and so forth. And then you can see for the multi-value, it's displaying it as this closing square bracket. That's not how it's stored in the database, but just so that you can actually see it on the screen, because there isn't really a character for, ASCII value, that'd be 253. You can see it that way. And in this pick system, you can enter it by doing control square bracket. If you're actually typing in, an attribute value manually and you need multiple values. But a couple other interesting things to note here. The phone number doesn't have any of those parentheses or dashes in it. And the values in the amount and the dates don't look anything like what they looked like in the reports. So we have the invoice numbers here. I believe that's the first field. And then we have the values here, the amounts, and then we have the dates. So dates, I think that's the dates. Maybe that's the invoice number. Anyway, one or the other. Yeah, pretty sure this is probably the dates. So dates are stored as the number of days since December 31st, 1967. So there actually wasn't a Y2K problem in PIC systems, because the dates just kept counting up, just however many days we are since December 31st, 1967. And again, because the values for numeric values are just stored as ASCII text for those numbers, you want to be able to do things like add them, obviously do math on them, sort them. So instead of storing the commas and the periods and all of that, they're typically just stored as the raw digits, and then a mask is applied for input and output. So the way the system knows how to handle the data and how to display it, and when you're inputting data, how to convert that data to the underlying format, is that you can have optionally, so it's not like a schema in a SQL database where you have to have a schema defining the table, or in essence, the table doesn't exist. You can have just data files with no dictionaries, but you can optionally have a dictionary for your file. And the dictionary is how you tell the query processor all about how you want to let the users interact with your data, meaning how you want to show it to them, essentially what column names or attribute names or field names you want available when you're doing that. So if I list the dictionary of the customer file, we can start to see that. And the way it's done here in the PIC system is every attribute is actually defined twice, once just with the number, and then again with the name, so that we can actually use names that humans might remember when we're writing those queries. So here, for example, the zip column, it's called zip, and it is, this is the type it is, and the AMC means where do I find it? And so zip is the 6th attribute in the multi-value data, in the data for this element, right? So the first piece of data is 1, and then there's the field mark, and then there's data element 2, then the field mark, data element 3. So the zip is the 6th attribute in the data. And we will show a maximum of 5 characters. And in reports, the column heading is going to be zip. So not too exciting. That's just a basic text field. But if we go down and we look at, so we can see that we're on the telephone field here. So the seventh element, the column label is in reports and displays is going to be telephone. And if we go to the next page here, you can see it has what's called this correlative. This is called different things in different multi-value implementations. But you can see here, it's using a masked decimal number display. And MD, these parentheses are just part of, telling it this is the parameter to this MD format string. But then it will display it as an open parenthesis, digit, 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 close parenthesis, space, digit, 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 dash, digit, 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 digit. So that's why, even though in the actual data, when we just looked at the raw data in the file, we saw 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. But when we view it in reports, it formats it according to this display mask. Dates. Remember, we just saw the number of days since December 31st, 1967. There's a format called D, and that just handles dates. So on input, it'll convert to the underlying number of days number, and then on display, it will display it again. There are various parameters you can use with D if you just want to show, the month or different formats, stuff like that. And last but not least, we can see here the amount. So those invoice amounts are stored in attribute number 9. And these have a conversion. So the conversion is to display, similar to phone numbers, we're going to mask the actual digits, the values. But we're going to do right aligned, and we're going to use 2 decimal places. We're going to display commas as a thousands separator. And then we also want to display this as currency. So put a $sign in front of it. But essentially what this says is that when the underlying value is, 1, 2, 3, 4, 5, that's how it's stored. But the 2 here for masked display means there's an implied decimal point in the position here with 2 decimal digits. So, it's not storing floating point numbers. It's essentially fixed point with an implied decimal point to allow for 2 numbers. I could do MR4, and then this number would display as 1.2345 instead of 123.45. So that's how that all works. You tell the system in the dictionary what it is that you're storing in the file, and then that lets me do the queries where I say, okay, show me again that customer file, show me the company field, show me the amount field, and show me the phone field. I think it was telephone. And it's wrapping here because the field isn't defined to show wide enough in the column view. But you can see here, again, you're getting the formatted output with the decimal point and the implied position of decimals and the telephone number with that mask. So that is the pick system. We haven't gotten into programming yet, and we're probably not going to do basic programming in this video, but I do want to switch over to something a little bit more modern, right? So this was the pick system operating system for the IBM PC. It worked the same way on a lot of other hardware that it supported, but this is obviously old, right? Nobody is going to run a dedicated standalone operating system like this anymore. They are going to want a multi-value database product that runs on their existing operating systems under, say, Unix, Linux, etc. Hello, sorry for the abrupt cut there, but this is future Matthew speaking to you now while editing the video. And this video got really, really long. So I think it makes more sense to cut the video here as part one. So, part one that we just watched was this old early PIC system running on IBM PCs. And I will post a second video tomorrow that looks at a modern implementation of a multi-value database. And we'll go through and look at that, see how it's similar, and go through an exercise of defining our planets database, really our planets file, and building all of that out. So thank you so much for watching this first video. I will put some links in the description. And of course, feel free to talk about PIC systems and the experience you have with them down in the comments. And you can expect the next video to post at the same time the next day, or if you're watching this in the future, you can just go ahead and go on to watch the next video right now, where we will look at a more modern implementation of a multi-value system and how you can get up and running with these things pretty easily. So thanks again for watching, and I'll see you in the next video.